In this video, we look at dot products, which is multiplying one vector by another vector. This dot product, hence the name. Now, what you get here is you get a real number. When you multiply a dot product by each other, here's the rule. Or when you multiply a vector by each other, which is called a dot product. So let's take a few random ones and see where we go. Let's take 2i plus j. Let's multiply that by I plus 2j. You can see that these vectors are quite close together on the I and j axis. So the rule is the coefficients of the i's 2 times 1 plus the coefficients of the j's both multiplied 1 times 2. The dot product of this one is 4. You might think, why are we doing this? Well, you'll see why in a minute. It's going to actually help us find angles between vectors. If we take the dot products, let's say ones that are quite far away from each other, let's say I plus 2j, and let's say there's one in the minus 5i plus 20j. You can see these would be quite far apart. We would get minus 5 times 1 plus 20 by 2, which is equal to 40 minus 5, 35. So the kind of rule with these guys, if you have two that are generally pulling in the same direction, obviously if this goes past a certain point, it's not going to be pulling in the same direction. We don't need to worry about where that is. They're obviously pulling opposite each other here. And there'll be a max point at which they need to pull to generate max force. We'll look at that later. So if they're quite close together and they're pulling in the same direction, it tends to have, or it will have, a positive dot product. And this diagram shows an example in this positive sector. The dot product here will be 4 times 5. 4 times 5 plus 3 times 2. It's going to give us a positive answer. You can see 3 times 2, 20 plus 6. Dot product will be 26. Let's see two that are kind of far apart. We take this one. The minus missing in the book. Let's multiply these two. We have our 4 by our minus 3 plus our 2 by our minus 1, which will give negative 14. You can see they're kind of pulling in opposite directions. So that's kind of an introduction to dot products. Why do we use them? Well, let's have a look at why we use them. We use them because if P and Q are two vectors, then the smaller angle between the P and Q is determined by this formula. Cos theta is equal to the dot product on top, and on the bottom the magnitude of each multiplied. So this formula is given indirectly, but let's have a look here at two vectors. Let's say I have minus I minus j as one vector. We'll sketch them now, and a second vector as 2i plus 3j. Let's get the angle between these vectors. Let's sketch them first. If we have positive 2i plus 3j going in that direction, we can have our x-axis say here, our y-axis and our j-axis. Label them I and j. You can call them x and y in your head until you get good at them. I and j, and let's say this is the vector 2i plus 3j. We'll call this the angle A. What about the vector I minus j minus I? Well, maybe I'll make a plus actually just to keep it up above. I'll keep it plus I plus. Actually, I'll do minus I plus j because my diagram is set up that way. Minus I plus j. I want one in here. It really is what I want. So here's my minus I, so that'll be a 1 and a 1 minus I plus j. We'll call this the angle B. We'll call the one in the middle, the big one, the angle C. So let's use our knowledge of geometry from juniors here to find C. So let's find the angle A using SOHCAHTOA with the straight sides always here. So we're going to use tan, the inverse tan of opposite over adjacent, 3 over 2, and that will give you the angle 56.31 degrees. And you can just write equals A. If we do the same over here, the reason I took 1 and 1 is so it will be equal to 45, but you could write the inverse tan of 1 over 1 equals 45 degrees. and that's equal to B. So C is equal to 180, take away those two, 180 minus 56.31 minus 45. So it's going to be 111.31, no, 101.31, which would leave 78.69 for C. So now let's use the formula cos theta. You might not have seen this one before. So the cos of theta will be equal to the dot product on top, which I'm going to write underneath dot product up here. We have minus I plus j times 2i plus 3j. So you're minus 1 by 2 plus 1 by 3. It's going to give 3 minus 2, which is equal to 1. So that's what goes on top, the dot product. 1, the Irish rain outside. The magnitude, these modular bars in here, the magnitude of each of these. So the magnitude of this one is square root 3 squared plus 2 squared. 9 and 4 is 13. And over here, the magnitude of this one is square root of 1 squared plus 1 squared. They're the ones you need to know. Be able to do that quite quickly. So the square root of 13 by the square root of 2, it doesn't matter the order. So that's the cos of theta. So type into your calculator the inverse cos of this guy, and you'll also get 78.69 degrees. So there's a couple of different ways to do it. Handy knowing these formulas. Let's see, do these questions come up in 2023? So now what I'd like you to do, always when you're going to the end of the chapter questions or the end of the unit questions, take some of the ones in the middle, maybe have a look at the ones at the start, see, look, they look easy. Do a selection from the middle. So try these ones. Pause the video, try these, and then try the next ones. Which will be a selection from the end, 18, 19, and 20. So give these a go on your copy, and then check out the next video for the solutions.